So, what we are doing is the next chapter. You've mastered Roman numbers. Yes? Yeah. Oh, of course. It just takes time, right? And then it's really not that bad. So we're moving on to chapter 6, which is our other number system, which is the Babylonian numbers. Like I said before, we're only looking at these historical number systems in 2 cases, and I restricted to those that actually have some relevance, some connection, some impact on our everyday life. Not that the Super Bowl numbers are every day, but to some people it might be. Babylonian numbers have an influence to the point where you've used Babylonian numbers today and yesterday, and you'll use it tomorrow. So it's more relevant than other number systems that have sort of faded over time. This one is still, apart from what it teaches us in terms of crossing over to chapter 7 and better understanding our decimal system, it is still relevant as well. Now I have a little video to maybe show you, because in reality they were limited to not having paper, but still they wanted to grow their civilization. Economically, they needed to keep record of things, trading and all kinds of things, and numbers are involved. Yet they didn't have any paper to write anything on. So they didn't let that stop them. They used clay instead. And by making indentations in the clay and then letting the clay dry, it was a way to preserve their writing. So a little video just to demonstrate that. Even though we don't have clay, it's good to keep in mind what they actually did.
Now all you need is a small piece of clay about the size of a golf ball or a table tennis ball, and to squash it out into a small disc. Here's our clay tablet ready to use. A small stylus. I've just cut mine from a piece of dowel, but in the old days I believe they used to use reeds, and then they used to cut timber much this shape. They used to draw lines, so I'll just draw some lines here quite a distance apart. They used to be write a lot smaller, of course. And believe it or not, for all the sophistication of their number system, they used just 2 symbols. One of them was this one. Just poke a small mark into the clay. That would be the number 3, and they kept going 4, 5, 6, 7, 8, 9. Easy. The next symbol they used was one like this, which represented 10, and they could make 30, 40, 50. The number I have represented there is in fact 59. If they wanted to represent the number 23, they do 1, 2, and 1, 2, 3.
All right, that's good enough. Now, so keep that in mind, but we don't actually have clay to write on. So what we're going to do is just draw those symbols. So our symbol or symbols are little flag guy like that. Looks like a little flag to indicate that the top is indented more and then it comes out. That's going to be our 1 symbol. 1. And then the 10 indented on the left, coming out of the clay a little, sort of like a less than sign. Or an I don't know what you see when you look at that. That's going to be our symbol for 10. Now, because you have a single stylus and you don't want to make indentations and then swap it with something else and then swap it again, it's not efficient, right? So you're limited to the number of ways you can angle this stylus while still making symbols that are obviously different. And they've settled on just these two. Only these two symbols. You have to make your whole number system with two symbols because of the material and the resources that they had. It was limiting them, but it wasn't going to stop them. So, if we just make a few examples, like he said, 23 is then going to be 2 10s and 3 1s. The 10s, in terms of sort of matching how they did it in the clay, you want them all to be clumped together. So they sort of stack diagonally on top of each other, and then the 3 1s, just 3 in a row. You want this is one representation. This should be nice and clumped together. Right? Not too much that you can't tell, but as close as you can get them. If you now have let's say 46. I'm going to stack 3 10s together, and the other 10 is going to be a little bigger and sort of connecting them. And then only 3 of these 1s are going to be in a row. So 3 and then a second row of 3 to make 6. Otherwise, it's going to get too long. You want a nice little round clump. I see confusing expressions on your face. What do you not like about this? Just everything. Think about the clay. Think about their limitations, right? You couldn't write anything. You just make indentations. It's all the material you had. Are you going to let your civilization just die out? No. No. And they were thriving based on this number system, yes.
Do you always go just off of 3s? So like
Always 3 1s at a time, yeah. Yeah. So we'll do a little more 1s because we go up to 9 1s. So let's do like, zoom out a touch. Let's do 18. So that's 1 10 and 8 1s, rows of 3. So 3 smaller ones, another row of 3 smaller ones, and then I'm at 6. So then 2 more. And the idea is to have all the rows sort of be the same, so the bottom 2 are a little bigger. But I'm not going to be uptight about that for you. You just have to make 8 1 symbols and 1 10 symbol. 10 before the 1. And they have to be as close together as you can so that you can see this as one thing. This is not a decimal system. Not decimal. That is one digit, if you will. One representation of 18. 18 all in one. So it's not separating the 10 from the 1s. That is not happening here. This is one, not symbol, one representation. So we go this way all the way up to 59. They've decided, look, obviously we can't stack too many 1s on top of each other. Obviously we can't stack too many 10s together as well. So they settled on 5 10s and 9 1s. Like the video showed, we want to represent, where is this 59? I went too far back. Is that his 59? We want to try and represent that, but it's a little hard to see on the clay. So we have 5, or my 10s, try and make them pretty in the beginning at least, but they deteriorate fairly quickly. No. because I want to count them as I do them. And then 3 rows of 3. Obviously, you want the same height or close to, so those 1 symbols are going to be a little smaller, right? So it's roughly the same height. Now, it seems very silly and inefficient drawing these, but that's not how they did it. We're just trying to copy them. You just make indentations, and it's very efficient, if you grow up with it, of course. So this is not actually how they did it, and it seems clumsy to draw these, but we're just trying to copy what those symbols looked like, because we could play with clay, I guess. It would be fun, but in a test you have to write it on paper, so I want to get used to drawing the symbols. Let's do exercise 6.1 on page, I don't know what page it is. Doesn't matter, 6.1. Where we now have our classic kind of question, convert back and forth. Just like with Roman numbers, the questions are the same. Converting back and forth. Given the Babylonian number, what is the decimal version? We all see it in front of us. I'm not going to try and copy them down. It's just a waste of time. 23. 2 tens, 3 ones, 23. Did we do 23 by accident? Oh, oops. Is everyone happy? You literally just count the tens and you count the ones. But they're all one thing. Then in B, what is the decimal number? 4 tens and 7, so 47. See, it's actually quite easy. Nope, still not buying it. Yes, the drawing is going to take a while to get used to it. I'll be honest with you, the first time I had to go and make sure I can draw them, right? But you do this like thousands of times, and you just have to make sure it's not too sloppy. A little bit of sloppiness is okay. I think it's easier than that because we have only 2 things to learn. But yes, yes.
I just mean that, like, if we're trying to relate this to pedagogy, we have to teach kids how to write pedagogy.
Yes, make a little tracing. And then you trace it. Yes, you're learning a new writing symbol, absolutely. Last one is 39. So in terms of identifying what decimal number it represents, frowns aside, you have to agree it's not the hardest thing ever. She's like, yeah, but I feel a setup is coming, or this is a setup. Yes and no. This is their system. So we're benefiting from the fact that their clay limited the symbols they could make. And the Romans didn't have that problem. The Romans could write because they got it from the Egyptians in one way or another. Now I have to go the other way. 22 is 2 tens and 2 ones. So if there are only 2 ones, I make them a little longer so the height is the same. But of course, do whatever you feel looks good. As long as I can tell the difference between a 10 symbol and a 1 symbol, I'm going to be okay. I like to be as authentic and accurate as possible, but in terms of testing, it's whatever, as long as, it's not whatever, as long as it's recognizable what you're trying to write, it's all good. 30. Just 3 tens. And you're done. There are no ones. So it's just not there. And lastly, I'm going to change that to a 48 because we've already done 59. Change it to a 48. So then I have 4. Sorry, that got, let's make them sharp, pointy. 4 tens. Haven't we done 48? What is wrong with me? Oh, no, it was 46. Okay. And then 2 rows of 3 and a row of 2.
So the ones have to go, you can't be more than 3 in a row?
If you want to be authentic, no, 3 threes. 3s at a time. So then you stack them under each other if you have more. Yeah. But again, if you want to make them all in a row, I'm not going to mark that as wrong. It's just going to take more space. If you want to put them in a row, it's totally fine. But the 10s technically are a stack of 3, and then if you have more, you make a new diagonal line. Doesn't mean you have to do this. That's the way you're going to see it in the book. That's the way I'm going to try and write it. Just trying to be as accurate as possible. If you want to put them all in a line, and it's clear what you're doing, it's totally fine. But you have to have a 10 symbol and a 1 symbol clearly distinguishable. It's not bad. Better than Roman, you have to memorize 2 things. Roman, you have to memorize, how many letters were there? 7? And then the subtractive pairs, and the line, and no. 2 things. You have to admire their efficiency here. All right, so then above that, there's a little table showing you numbers 1 to 20, but I think our examples covered enough for you to be able to fill in the gaps. 6.1 done. See, so easy. No? Less frowns, so that helps. It's getting better. I think it's easier because you have 2 things to write. You just have to understand how many of each of those symbols you are allowed to have. So you can have 5 10s and 9 1s. And then they decided, I guess based on trial and error, that any more than that, and it's hard to just look at the number and know the quantity, right? That's still what you want. For our decimal system, you look at a number, you know the quantity. They have the same requirements. They want to look at the clay and know exactly what's written down without having to decipher it and count and anything like that. So 5 10s and 9 1s is as far as they can go. So now the question then, of course, is, what about larger quantities? They had a lot of trading going on, so obviously the numbers got larger quantities. What if I want to write 73? For example, 73. What do I do with 73? So this is where they decided, okay, we go up to 59 for our single place representation. Any more than that, and we're going to have to break this up. So they decided to count in 60s. Count in 60s. Meaning that 73 is bigger than 60. I'm going to say it like this. I'm going to say it in English first. Whoops, I don't want to do that. One group of 60. And then, how much more? 13 left over to make 73. So that means one group of 60 plus 13 leftovers. Is everyone happy that that makes 73? Okay. Because I can only go up to 59, I am now going to make 2 places. So this is a place value system. From right to left, the right side is going to count the leftovers, or the ones. The next one in, towards the left, is going to count the number of groups of 60, or the 60s. So let's write it in brackets first. There's going to be one group of 60 and 13 left over. So it's going to be a 2-place number counting 60s and leftovers. But of course, they don't write a 1 like that. How do they write a 1? With their clay symbols. I think I went to the wrong color here. Come on. 1. And not 13, but their version of 13 is a 10 and 3 ones. So clearly notice the space. The space says everything. The space says how many 60s, how many left over. Without that space, it's hard to read, and it might not mean the right thing. Yes?
Is it hard to differentiate the number 1 from the number 60 if they're just about...
One thing at a time. Let's put a pin in that. Just don't want to overwhelm her frown. I'm trying to get rid of her frown. Right? And that's going to make it worse. So, one thing at a time. But we do have to address certain things. Let's just practice this for now. And we're looking at exercise 6.2. Again, converting back and forth. That's still the only issue we have. Getting used to how they write certain quantities and how to read those quantities. So, I'm going to do an in-between step. In the first one, I see 2 places. 1s and 60s are being counted by those 2 places. Their representation for the 60s place is 1. Their representation for the leftovers, or the 1s, is 35. This is a conversion question. You can write decimal numbers. Right? Only for the arithmetic you couldn't. That's not what we're doing here. You write whatever you want to write to find the answer. Mix and match and do whatever you want to do. This is what maybe helps me right now. And that then implies 1 group of 60 plus 35, giving me 95. We're counting in 60s. There are some theories on why 60 instead of other surrounding numbers. The theory is that 60 splits up into a lot of different things, 5 and 12, 6 and 10, all kinds of things. And the surrounding numbers don't have that many ways to split it up as 60 does. But whatever the reason, that is what they did. How do we feel about that? 95. All right. Now, do whatever you need to do, right, to get to the 95. I'm just sort of guessing this might help, focusing on the places and what they represent. You don't have to. You can just write 95, as long as it's correct. So here in the next one, I see 2 places again, so maybe that helps you. If it doesn't, please tell me to stop. Unless you're watching the video, and then you can't say anything. Then the 60s place, 3. And the 1s place, 41. I write it in brackets because that's just temporary, right? So 3 groups of 60, which means multiplication, and 41 left over for a total of, put a circle around it so I can spot it, arrows, answer here. What you do on the way to get that, totally up to you. Now, if you make a mistake in the 221 because of your calculator or whatever, it's good to see the details so I can give you something if I can verify, you did know it was counting in 60s, you just made a little calculation mistake. If there are multiple marks to give, that would just give you a little bit of safety in case a silly mistake happens. We have a lot of time. Ask questions if you're not sure. 2 places again. Should I keep doing these places? I'm doing it anyway. Oh, 10 in the 60s place. 50. See there, they do it sort of in rows. That's the only font I could find, so it's going to be it. So what is the calculation? Giving me the decimal quantity. 10 groups of 60, 50 left over, 650. Too easy? Yeah. It's pretty easy. I think it is. It's pretty, I guess the word is elegant. Simple in design, yet it does exactly what you need to do. And they wouldn't have come up with this if they had paper. I don't know what they would have come up with. Who knows? But they did not have paper, so they came up with this. This is what you grew up with. This is what you go to school with. This is as natural as anything else. You don't know about paper. It's not a concept you're aware of. Any questions on how we convert from Babylonian to decimal? Is it because you don't know what to ask, or because you're not speaking anymore? Or because it's not that bad? Not that bad. Now we just want to check the other way. Converting from decimal to Babylonian. Now, that is going to be the more difficult way if you had to pick a difficult side. Because you're given, let's say, 100. You want to split it up into how many groups of 60 plus how many are left. Now, maybe let's make a little table. Because I know what's coming, and the table might help. Let's say here, place value. 60s and 1s, right? The different places. And then, let's say, number of groups. How many 60s can you fit? Oops, that was supposed to be a line. Straight line. What have I used? I found this very beneficial over the summer. It really helped. Especially when the numbers get bigger. Right now, 100 isn't big, I know, but... so I'm going to fit in as many 60s as I can. How many 60s can fit? Only one. How much have I used of the 100? 60. How much is left? 40. So the 40 goes into the leftovers, and I need to use all 40. I've used all 40. I have nothing left. I have to have nothing left in the end. So this is going to be one group of 60 plus... That was the funniest sneeze I've ever heard in my life. I hope that was on video. Forever. Probably, maybe not. The microphone's not that great. Now, when the numbers get bigger, the table may or may not help you. It's totally optional. You don't have to do it. So again, now I have two places, counting 60s, counting 1s or leftovers. So we said it was one group of 60, maybe a temporary there, and 41s, implying my Babylonian number, 1 and 40. Space between them. If you have a certain way you want to write the little 1 symbol and the 10 symbol, as long as I can tell them apart, it's all good.
So the place value is 60.
We're always counting in 60s.
Yes. So where did you get the 1?
How many groups of 60 can you fit into 100?
Oh.
Just one.
Yeah.
Because 2 would be in 120 and I don't have that. Then how much is left? 40 is left, and the leftovers are all collected by the 1s. So right now the table is overkill. Soon it might be something that helps you. All you need is that. And the 1 goes over here, and the 40 leftovers go over there. The 60 is not an optional thing. The 60 is set in clay. Get it? You can't erase clay. B. It's always going to be 60. That is not changing. 324. But as the number gets bigger, sometimes some people have a little trouble fitting in how many 60s can go in. That's where the table might be useful. You don't have to use the table. Let's do this one without a table. How many times does 60 go into 324? Everyone happy with 5? 5 groups of 60. That uses, you can maybe write a little note here, uses 300. That means I have left 24. That means 24 will be left. So that means you don't need to write this temporary either. It's totally up to you. I have 2 places, 5. So that's 3 and another row of 2, space, 24. So you do whatever you need to do to get to that answer. But out of the 2 directions of conversion, this one may be a little bit, there's a little more to do, a little more opportunity for mistakes in the arithmetic, potentially. I don't want to go too fast. Let me know how it feels. 1,337. How many groups of 60? How do you know if my mental arithmetic is shaky at best, and if I ever were to do grade 5, I'll get a substitute? Maybe do the math, someone else. Yes, you could do that. If you're committed to doing this in your head, pick a number you do know. 1,200? 1,200, and then how many is that? 20? That's still far away, so I still have 137 left. 120 would fit 2 more 60s, so 22. But suppose you don't want, screw this mental nonsense, my brain. Put in 1,337 divided by 60 on your calculator. What do you get? No, what exactly do you get? You don't get 22.
No, you get 22
Point.
decimal, blah, 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 blah. Keeps going. Well, I can remember it.
No, just those that some people need to see it. All right. You're right with the blah, blah, blah. But it gives you the 22. You don't care about the little portions of 60. You only care about how many whole groups of 60 go in. Whoa, whoa. Not paying for antivirus, are you kidding? That's not going to happen. But now we have to know how much have we used. How do we figure out how much have I used? 22 times 60. Which calculator says 1320. So how much, well, it's supposed to be left over. Sometimes it's easy. Sometimes you need 1,337 minus 1,320, and you get 17. That goes right to collections at the end. So let your calculator help you. It's totally up to you. Again, whatever path you take, mental math, calculator, divine intervention, whatever works, as long as it gets you to the answer. So 22 is 2 10s. I'm not judging, whatever works. Then a single 10 and, 7. Back them nice and tight. As long as you have that space in between. This one might take a little bit of practice, and whatever method you're going to pick, I would say commit to that. If you're going to pick the calculator route, make sure you can do that. Always do the same thing for a while so that you can get used to it. Unless you're very comfortable, then you can flip and flop. Well, maybe do this one in my head. Nah, maybe calculator this one. Maybe a little prayer. Mix and match. But not in the beginning. If this feels shaky, let the calculator help you. Or just make sure you get the right answer. All righty. How big can we go here? It's still not infinitely big. We can get bigger numbers. But with 2 places, we're going way too fast. It's making me uncomfortable. I'm not going to go this fast. Backtrack. I'm going to answer his question. What about the quantity 720, for example? Well, an example, 720. How many groups of 60? How many left over? 12, she said? Okay. Let me erase this. You put it in your calculator, it says 12 exactly, which means nothing is left over. You've used all 720. So now, perhaps at some stage they then said, okay, I'm going to go 12. Like the Romans, just empty space. But now, if this is among other calculations, it's hard to identify that that space is a little bigger than normal, meaning there should be another place here. What if your other numbers are squeezed together and then maybe your other calculation here is a 1 and now, oh, I don't know how to read that anymore. You can easily read this as just 12, which it's not. So they recognized this and realized that there has to be something in that place to make sure it doesn't get lost. And make sure that when you look at that number, you understand it's a 2-place number, 12 groups of 60, and nothing else. The Romans got away with it because they didn't have places. It just all squished together. There has to be a nothing symbol. There has to be a symbol to show this empty place. So yeah, I'm jumping the gun a little bit, but they decided on 2 little triangles. Because again, they don't want to swap out their stylus or their reed. They just want to angle it a little bit differently and just make a little double triangle indentation. So, whoopsie. So 720 would be 12 groups of 60 and no ones. So that you know that's a 2-place number. Yes?
If we get into bigger numbers, is it possible to have 2 zeros?
Whenever a place is now empty, you have to show that symbol. That is now a new 3rd symbol. Yeah. But we'll leave the bigger numbers for tomorrow. But yes, anywhere where your breakdown has a 0, you need that guy. Now, they didn't see this as a 0, but for all intents and purposes, that is equivalent to 0. Only in India did they recognize that nothing is the same as something, and 0 is a number just like anything else. At least they recognize that there needs to be a symbol to represent that empty space. But you can see it as a 0. It's just interesting to know that they didn't see it as a number. But you need something, yes?
Let's say it was 72,000, like an extra 0.
One thing at a time. Those are larger numbers. So at this point, at this stage, the largest quantity that we can represent with 2 places is 59 and 59. This will be our 60s, this will be our 1s. That's the largest number you can make, right? That would mean 59 groups of 60, because any single place cannot go above 59. That was their rule. That is what they decided. That is set in clay, not going to change. So 59 groups of 60 plus another 59. So that is as big as you can get, 3599. So tomorrow we will see, well, obviously maybe you are a very successful trader and you have more than that to trade. You want to keep record of it. What do you do? So we're still a little bit limited. Where the Romans saw the larger quantities and said, let's put a line over it. The Babylonians were a little bit, I don't say better, wiser in their decision.